Good morning. So today we're going to be working with AA5b-1, which is solving linear inequalities. For some of you, this may be an Algebra 1-2 review, and for some of you, it may be a reteach. So we're going to start with looking at our number lines and noting our smallest and largest values and that kind of thing. We're going to talk about the different markings and notations, but I wanted to give us a brief overview here. When we're looking at this number line, our lowest point here is -5. This arrow indicates that we're going out to infinity. So what that means is if I am writing this for a value of x, x can be anything greater than or equal to -5. So in words, a solution can be anything greater than 5 and that includes the number -5. So our interval notation basically takes our lowest point, so we're going from low to high, our lowest possible value, which in this case is -5, and because that -5 is included, it's a bracket, and then -5, and then a comma, and since this is going out to infinity, that's what goes down here, we make that a parentheses because you're never actually going to reach infinity. We'll talk more about that notation on the next slide. On number 2, if we look at this inequality, -2 is less than x, which is less than 6. In words, the easy way to say that is a solution is between, or can be between -2 and 6. Oops. And that does not include, so excluding -2 and 6. And the reason that we know that it's excluded is because these symbols right here don't have the number, or don't have that line under them indicating the or equal to. So what that looks like on a number line is an open circle at -2 and an open circle at 6. That indicates those values are not included in our solution set. And then it's anything in between them. So if we think about our lowest value for this solution set, we can think about 2.00000001, and that can go, those decimals can go out to infinity, as well as our highest value would be like a 5.9999999, which would also continue out to infinity. So we have an infinite number of solutions in between -2 and 6 if we're looking at real numbers. If we're looking at whole numbers, then we have a finite number. But anyway, for inequality, we already know that that's the -2 is less than x, which is less than 6. Our interval notation, because of those open circles, we're going to use parentheses. That tells us that the -2 is not included, and then our highest value of 6 also not included. So these two things, the inequality and the interval notation, those are two different ways of telling us exactly the same thing. So to make sure everybody's clear on what these symbols mean, I want to make a couple of notes here that we're reading from left to right. So for example, on this first one, if I have x and 5 here, then I'm reading that from left to right as in 5 is greater than, I just totally said that wrong, x is greater than 5. So so I'm going to take out the x and the 5. So this first one, this is greater than, When we flip that around, it becomes less than. And these are both excluding. So the values that we input there are not included. The markings, if we're on a number line or on a graph, these are both shown with open circles. With an interval, these are shown with parentheses. And we're not doing this today, but if we are graphing a line or any other type of parabola or whatever else, then we are looking at dashed lines to indicate that those values are not included. Our next ones, with the line under it, that tells us that the values are included. So that changes this from greater than to greater than or equal to. And if we flip that around, it changes to less than or equal to. So those two include our values in the solution set. We make those closed circles for our number line or graph for that matter. We use brackets. And I have like the brackets put together on the ends here, but you can have an inequality interval that has both a bracket on one side and a parentheses on the other. So just make sure you understand that those are, you can mix those. Then if we're looking at a line or parabola or something like that on a graph, those are solid lines. The last one we're not really going to be working with today, but that, the equal sign with a slash through it, simply means that they're not equal. And we're not going to get too much into the weeds on this. This is just an open circle, and we'll move on from there. So something that I want to note is how similar solving equations and solving inequalities are in terms of linear equations and inequalities. I'm going to start solving my equation by taking the smaller x from both sides, and I'm going to add this 3 to both sides with the purpose of getting my numbers, my constants, on one side. So 9 plus 3 is 12. Drop down my equal sign, and 7x minus x is 6x on the other side. And I can do that in 2 separate steps. I'm just saving a little time for the video. Divide both sides by 6, and I end up with x equals 2. One thing to note, that x equals 2, if I flop that around to, 2 equals x is the same thing as x equals 2. These are saying exactly the same thing, because when they're equal, we don't need to worry about what side is on what, just that they equal each other. Now we have this inequality sign here instead of the equal sign, but our steps aren't really going to change. I'm still going to subtract x from both sides. I'm going to add the 3 to both sides. So I've got 12. Drop down your sign is less than 6x. Divide both sides by 6. And I have 2 is less than x. Something to note that is different from this to this is if I flip this around, this says x is less, that doesn't say x, sorry, 2 is less than x. If I flip that around, I need to flip the entire thing around. So this would be x is greater than 2. So from here to here, when I flip everything around, I flip all of it around. So these are equivalent statements. They're just said differently. If 2 is less than x, then x is greater than 2. So what I would do if you're watching this video and you haven't gone over any of this yet is I would take a minute and do some of these yourself. I'm going to do the first one to kind of show you what I'm expecting, and then I would pause the video if I were you. So to solve here, we're going to divide both sides by 3. So I end up with x is greater than 4. On the number line, that'd be an open circle going out to the right for any values greater than 4. To pick a number in the solution region and test it, I want anything over here. So I'm just going to use 5. I'm going to go back to my original equation, so 3, and then instead of x, I'm going to put 5 is greater than 12. 3 times 5 is 15. So I have the inequality 15 is greater than 12, and that is true. 15 is, in fact, a greater number than 12. So here's where I would pause and try a few of these for yourself. So the next one, I'm going to divide both sides by -4. So I have x is less than -4. Open circle at -4, going out to the left. If I want to pick a number over here, I'm going to go ahead and pick -5 this time. So I'm going to do -4 times -5 is less than 16. So I've got positive 20 is less than 16, which is not a true statement. 16 is actually less than 20. So this one was not correct. On the next one, divide both sides by 5. So I have x is greater than or equal to -7. So I've got a closed circle at -7 going out to the right. If I want to pick something in that solution region, easiest thing to pick there is going to be 0. So I'm going to do 5 times 0 is greater than or equal to -35. So 0 is greater than -35. That is true. So that one works. Next one, divide both sides by -3. That was kind of messy. So I end up with x is less than or equal to 5. So if I go to 5, put a closed circle, go out to the left. I'm going to pick 0 again as my possibility to check. So -3 times 0 is less than or equal to -15, which gives us 0 is less than or equal to -15, which is not true. 0 is greater than -15. So that one is also not true. So if we look at what's happening here so far, this line and this line did not work out, and they have something in common, which we're going to look at the next slide as well. What we have in common in all of these is when we solved, here we divided by a negative, here we divided by a negative. So on the next one, here we have a fraction, which if you remember, a fraction is simply the top divided by the bottom, and to undo division, you multiply. So if I'm dividing by 3, to get rid of it, I'm going to multiply by 3. So multiply by 3 on both sides. X is less than 12. So I'm going to just throw 12 on here. I'm not really going to worry about where my values are, like that there's 12 spaces between them. I'm just going to throw them on there. I always like to see 0 as a reference point. I'm going to have an open circle at 12. X is less than that, so I'm going to go out to the left. And I'm going to pick 0 as my checkpoint. So 0 divided by 3 is less than 4. 0 is less than 4. That is true, so that worked. On the next one, I'm going to multiply both sides by -4. So I have x is greater than or equal to -64. That's going to be somewhere down here. 0 is going to be way up here. So closed circle at -64 going up. I can use 0. I can use anything divisible by 4 as well, so I'll try something divisible by 4. So in this case, I'm going to do, let's say, a positive 12, or let's just do a positive 4. So if I plug in positive 4 for x, divide that by -4, see if that works out. I end up with -1 is greater than or equal to 16. That did not work out. The next one, I've got x divided by 5, so I'm going to multiply both sides by 5. So x is greater than -35. Throw my -35 on here, 0 somewhere up here, open circle at -35, arrow going out to the left. Just kidding, to the right. I'm going to go ahead and use 0 again as my point my solution region point. 0 divided by 5 is greater than negative 7. Gives us 0 is greater than negative 7, and that is true, so that one worked. And the last one, multiply by negative 3. So x is less than or equal to a positive 15. Got 0, got 15. Close circle at 15. Shaded to the left. I'm going to go ahead and use 0 again. Pardon me. 0 divided by negative 3. Is less than or equal to negative 5. 0 is not less than or equal to negative 5, so that one did not work. So once again, we have some here. This line here didn't work. This line here didn't work. And if we go back to the previous slide, here we divided or multiplied by a negative, and here we multiplied by a negative, and none of those solutions worked out. So what we need to know, and what you definitely need to put in your notes, is that when you solve a linear equality, if you multiply or divide by a negative number, you must flip the inequality symbol. And there are two ways to look at this, and I'll show you both. Okay, so I have this example, negative 6x plus 2 is less than 14. If I use my normal solving methods with this, subtract 2 from both sides, I have negative 6x is less than 12, divide by negative 6, divide by negative 6, I have x is less than negative 2. But if I check something in that solution region, so something less than negative 2 would be negative 5. So if I put negative 6 times negative 5 plus 2 is less than 14, I've got 30 plus 2 is less than 14. So I end up with 32, which is not less than 14. So this does not work. So what I have to do is remember way back up here that I have to flip that sign because I divided by a negative number. So I have to change that to x is greater than negative 2. One way to do it, it does require that you remember to flip the sign. Alternatively, what I can do is make sure I don't have a negative with my x. So I can add 6x to both sides, subtract the constant to get it to the other side. So I've got negative 12 is less than 6x. Divide by 6, we have x is greater than negative 2, or negative 2 is less than x. So these two are equivalent statements, and either one is fine. It's just with the second one, I did not have to remember to flip my sign. The first one, I need to remember to flip the sign. And if you check every time, you should catch it, but it's definitely a struggle to make sure that gets taken care of. We also have inequalities with multiple intervals. I'm going to show you two ways to do this. One of them will work every time, and one of them works better with linear equations, or inequalities, I'm sorry. So the first one is I split off the middle section with the negative 13. So I have one inequality that's negative 13 is less than or equal to 2x minus 7. Split off the other one to be 2x minus 7 is less than negative 5. In both cases to solve, I'm going to add 7. Then I'm going to divide both sides by 2. Over here I get x is less than 1. Over here, I get -3 is less than or equal to x. Then I put it all back together for my solution of -3 is less than or equal to x, which is less than 1. So that's one way to do it. You can do that if you want to. It's certainly, when we're talking about compound inequalities that have nonlinear stuff, this can be a better method for it. However, for linear stuff, what you can do is basically what we already did, just do it to both the left and the right side of that inequality. Add 7 to everything. So I've got -6 is less than or equal to 2x, which is less than, equal to, less than 2. Divide everything by 2. So I've got -3 less than or equal to x, which is less than 1. If I'm looking at interval notation, that's going to be a bracket because of that, with the -3, comma, 1 for my highest value, and then because of that sign, that's going to be parentheses on that side. If I'm looking at a number line, I have my 0 here, -3 somewhere over here, 1 here, closed circle at 3, open circle at 1, everything in between. So that is for that. Last thing I want to discuss, and this I don't really need, don't really need that top part because we just did that. I'm going to zoom in on this part. If I solve these inequalities separately, -5, -5, I got 6x is greater than or equal to -12, divided by 6, divided by 6, x is greater than or equal to -2. Over here, got +4, 3x is less than 6, divided by 3, x is less than 2. So I have these two inequalities. If I'm looking at the difference between and, so I have graph the region, which is a solution to both of those. I have, if I'm looking at the x is greater than or equal to -2, go to -2, close circle, going up. Oh, that was really bad. And then x is less than 2. That's going to be an open circle at 2 going down. So the part that is a solution to both of them is, whoops, that didn't mean to erase that, is this space in between here. So now I want to erase those. My x is less than 2, open circle, closed circle at -2, and the space between. So that region is a solution to both of them. If I'm looking at the OR region, that means that a value can be either greater than or equal to -2, or it can be less than or equal to 2. So it can be in any of these regions. So I'm looking at one or the other. Basically, I'm looking at everything on this number line. Because if it's anywhere, it's meeting one of those criteria. So that is it for 5b-1. Make sure that you are up to date on this stuff. We'll head to 5b-2, which is quadratic inequalities, next class. Have a good day.